Hello, so this lesson is going to be an extension of the pneumatic stuff, but we're going to move on and we're going to look at something called air bleed, okay? Air bleed is a methodology where we can use a really gentle leak from the system, a deliberate leak at really low flow rate, and if that leak gets blocked, then we can use that to trigger valves, okay? Air bleed Air bleed typically takes the form of using a 3-2 valve with a spring return diaphragm actuator on it. So you get main air. You see the output port's coming back to the exhaust. That's the proper internals for a 3-2 valve, and we use a diaphragm. I've got a diaphragm. I think I've got a diaphragm here to show you in real life. Okay, so there's a diaphragm spring return 3-2 valve, and what we do is we attach what we call an air bleed to it, and it's just an open hose, but we do need to be really careful, right? So what we have is an air bleed, an open hose, and the symbol for an air bleed is that. So that's the symbol for an open hose. This is the open end to the atmosphere, so air would be coming out of that. So we'd have a main air signal, but we wouldn't connect a T-piece down to the diaphragm valve, right? We wouldn't have main air here, because that would mean that main air was coming out of the air bleed, so that would be like an extreme leak. It would be like really loud. If the hose wasn't fixed in position, it would be whipping about wildly and be really dangerous. Plus, things that we were going to block that air bleed with, they might get damaged by the airflow and the air pressure that's coming out of there. This is the kind of thing that might find itself being used on like a conveyor system, where you only want something to happen if a box arrives. This is like object sensing. This is to sense objects. Yeah. So the idea is the leak is permanently happening, and then maybe the hose is sitting out just at the side of a conveyor belt, and if a box comes along the conveyor belt and blocks the airflow, as soon as it blocks the airflow, the 3-2 valve will get triggered, and then perhaps a ram would come out and shunt that box into a particular location. You could use it to sense a difference in boxes, like for instance small boxes have to continue on unimpeded, but large boxes have to be pushed off the conveyor belt at this point. So you could have an air bleed sitting high up, anything small passes under the air bleed and nothing happens. Anything large that blocks the airflow suddenly gets shunted off by the action of a 3-2 valve that's, for instance, triggering a single acting cylinder. Yeah. So that's that kind of system. That's the kind of the basic. The idea is you wouldn't want to have main air coming out there, because main air, if it was high enough, could tear the box. Or one of the examples they gave in an exam once was using air bleed to detect like pastries on a food line, on a food manufacturing line, and the idea is that pastries are really sensitive. You don't want to actually touch them with anything. So if you have a really gentle airflow coming out of the system onto the pastry could block that really gentle airflow enough to trigger the 3-2 valve. You definitely wouldn't want main air coming out onto a pastry, because you just rip it to shreds. So what we have is a flow restrictor in here. We only pretty much ever use unidirectional flow restrictors, so it would be that way with a cone pointing towards the T-piece. That's how we would make them in the school. I'd have a connection come from main air through a unidirectional flow restrictor into a T-piece, and we would just leave one side of the T-piece open, just wouldn't put a hose in it, and then the other side would be hosed to the diaphragm valve. Let me see if I've got a diaphragm valve here. Yeah, so here's a diaphragm valve. It's really big. I think I've shown you this before. So it's got the input on the bottom, so that's the input port, that's the output port. The exhaust port is here with nothing in it. You wouldn't put a hose in there. This is the diaphragm actuator on the top. You can see it's a big disc. Yeah. And you can see a black line running across there, and that's just a rubberized membrane. That's the diaphragm. Diaphragm is a really thin slice of rubber, just like the skin of a balloon. So if we introduce an air pressure in here, airflow in there, that diaphragm will inflate, it will deflect like a balloon inflating, and we can use that deflection to trigger the 3-2 valve. So that's a diaphragm valve. Yeah. And that's an air bleed circuit. So air bleed is used to sense objects, and air bleed should always be really low pressure. so that it doesn't destroy any of the things that it's sensing, and so it doesn't endanger anyone that's in the area of the system. And we can use that to trigger, again, that actuator could appear on a 5-2 valve or a 3-2 valve. We could use that in a system that has a double acting cylinder or whatever. Right, so your task, short and easy one this time, is to redraw that circuit, redraw, create a parts list, and write out an explanation of operation using the correct terminology. Remember, I'd expect to see things like cylinder out, stroke, cylinder in, stroke, you know, that kind of terminology, or cylinder positive, cylinder negative, 3-2 valve actuated, or you can name them. I mean, that could be valve 1, that could be cylinder A, so that in your explanation it's a little bit shorter. Look back at the previous examples. I know it's been a while since I posted a video because I've been in school, and this is a short one just to kind of keep you going. Okay, thank you.